Hey everyone, happy Monday. I am super excited to be back. This is Mrs. Verostek. I'm back to finish the last few weeks with you. A few things that I want to say before I get started is I want to make sure that I reference a few posts that I made over spring break. Since I was super excited, I got on and I made some posts. So the first post is a long paragraph, multiple paragraphs listing what our schedule is going to look like. On Monday, Wednesday, and Friday, you are going to be given a question of the day. Monday's question of the day is going to be posted with a video, just like today's. And then Wednesday and Friday, they will not have videos. On Tuesday, you are going to have to log on to the website deltamath.com. Miss Jenkins posted a video on how to do that, a tutorial over spring break, so make sure that you go back and you watch that video. It also gives you the code that you need. You need to make sure that you log on to that before tomorrow. That way I can help you for tomorrow's assignment if you need it. Third thing is if you turned stuff into Miss Soster over the course of the last 2 weeks and your grade is not correct in Power School, you need to make sure that you contact myself or Miss Jenkins so that we can update your grade after you resend us your work, okay? Now, each week we're going to be learning or focusing on a new topic. Everything is going to be review. So our first week we're focusing on solving equations. Now, there are 5 steps to solving equations: 1, 2, 2b, 3, and 4. The first thing I want to remind you of is if you have an equation and there's the distributive property, which means there's a number on the outside of the parentheses, you need to multiply that number on the outside to each of the bases on the inside. Okay. After you look for the distributive property, you want to combine like terms. And I'm just going to talk about like terms up in the corner here. Like terms are saying 2x and 4x, or negative 3y plus 7y, okay? When you combine like terms, remember the letters have to be the same and then you add or subtract the coefficients. So that reads negative 3y plus 7y, which gives me a 4y, okay? After you look for the distributive property and you look to combine like terms, you want to make sure that if there are letters on both sides, you add or subtract the smaller variable to the opposite side, okay? Any equation that doesn't have any of these steps, you just skip and go on to the next step. After you do those first 3 steps, you have a 2-step equation. So you add or subtract the number without the letter, and then you multiply or divide the number with the letter, okay? Now, when you're solving an equation and you get an answer such as x equals any number, x equals 2, x equals negative 4, that means that there is one solution, okay? It's important that you know these 3 different types of solutions for today's problem of the day. If you solve your equation, the letter drops out and you have a false statement, meaning the statement looks like 7 equals 6. Well, that's false. Or negative 3 equals 3. That's also false. Then your answer is going to be no solution. Whereas if you have a true statement, okay, such as the number equals itself, 4 equals 4, or negative 6 equals negative 6, then that means your answer is infinitely many solutions, okay? Now, I would highly encourage you to take a second, pause this video, and take notes on a sheet of paper about this top half, because you're going to want to use these top half notes throughout the entire week. You're not going to want to have to go back and rewatch videos over and over again. So just pause the video, take notes on the first 5 steps to solving equations, and then take notes on the 3 different types of answers that you might get, okay? When you're done pausing the video, go ahead and hit play, and let's look at today's question of the day. The question reads, select a box to identify whether each equation has no solution, one solution, or infinitely many solutions. So we've got 3 different problems here, okay? Notice here how I just rewrote them on the underneath the problem. That way I have workspace. Okay, so let's take a look at question number 1. Now, when solving these types of problems, you want to go through the steps. Is there the distributive property? Do you see parentheses with a number on the outside? No. So then you skip that step. And then you say to yourself, okay, do you see like terms? Now, remember, with like terms, you have to look on the same side of the line. You cannot cross the line. So do you see any like terms on the left side? No. Do you see any like terms on the right side? No. So we skip that step. Step 3, do you see letters on both sides? I do. I see a negative 2x and a negative 3x. When simplifying, the step says to move or add or subtract the smaller of the two variables. Well, negative 3x is smaller, so if I want to move it to the other side, I'm going to add 3x on both sides. Notice here how the x's are on top of the x's and the x's are on top of the x's. Make sure you keep your work organized. Okay? Now, on the right, the 3x's cancel out and I drop down a positive 2. On the left, negative 2x plus 3x is 1x, and I'm able to drop down the plus 3. Now notice I have a two-step equation, so I want to add or subtract the number without the letter. So I'm going to subtract 3 on both sides. It cancels on the left side. I'm bringing down my 1x equals 2 minus 3 is negative 1. Okay, last step is to multiply or divide, in this case, the number in front of the letter. And I get that x equals negative 1. Okay, now, with the answer of x being negative 1, I want to go up to my box. Okay, notice how x equals negative 1 is not any box, the answer is not in any of the boxes there. So what does that solution mean? Based on my definitions up above, that means that I have one solution. Okay? Now let's go ahead on number 2. Once again, what you're going to notice is that there is no distributive property. There are no like terms because you cannot combine on the left side. You cannot combine on the right side. However, there are letters on both sides. Now, negative 2x and negative 2x. When you're thinking, you might say to yourself, well, one's not smaller than the other. So let's just move one. It doesn't matter. Let's move the one on the left to the opposite side. So the opposite of a negative 2x is adding 2x to both sides. Okay. On the left, they cancel out, and I'm able to drop down the 3. On the right, they cancel out, and I'm able to drop down another 3. Now, 3 equals 3, based on our definitions from up above, was what type of solution? Infinitely many. That's a true statement. Okay. And now last one, number 3. Okay. No distributive property, no like terms. I have letters on both sides, so I want to move the smaller of the two. So negative 2x, right here, that one's smaller. So I want to add 2x to both sides. They cancel on the left, and I drop down a positive 3 equals 2x plus 2x is 4x. I'm able to drop down the plus 3. Okay. Now I have a two-step equation, so I want to add or subtract the number without the letter, which is the plus 3. The opposite of adding 3 is subtracting 3 on both sides. Now, 3 minus 3 gives us 0. I do not just leave this side blank. I have to put the number 0 because that's what 3 minus 3 is. Drop down the equal sign, drop down the 4x. You cannot stop this problem here and just say, oh, that's a false statement, because the letter is still in the problem. So I need to get rid of that 4 in front of the x. That's invisible multiplication, so I'm going to divide by 4 on both sides. It cancels out, and my x still drops down on the right side, and 0 divided by 4 is 0. Notice here how my letter is still in a problem. I have an answer. Okay, that means when I go back up to my boxes, that gives me one solution. So I want to make sure that I check this box. Okay. Now, make sure you take your time on today's question of the day. These questions are going to go in for correctness, especially since I'm giving you a video that basically walks you exactly through how to go ahead and do this. Okay? If you have any questions, feel free to email me, and I will talk to you soon. Bye-bye.